Hi guys, welcome back to our channel Geeks Rendezvous, and I really hope that you guys liked the last lecture. And if you guys have any suggestions or questions, please make sure to leave them in the comment box. So in this lecture we're going to study about meta-isomerism. We learned about chain and position isomerism in the last lecture. Now we're going to move forward and study meta-isomerism. So what is meta-isomerism? Meta-isomerism can be shown by only those molecules which contain bivalent or polyvalent functional groups. Let me give you some examples. For example, the ether group, or we can say that the ketonic group, or this, or aldehydes, or alcoholic group. So these are few examples which show meta-isomerism. I will show you how they show meta-isomerism, what exactly meta-isomerism is. So bivalent molecules, bivalent functional groups are those which have valency either 2, and polyvalent are those which have more than 2 valency. So what is meta-isomerism, and how do compounds show meta-isomerism? So let me give you an example. Let's take this. This is ethoxyethane. Okay, so we have 2 carbon atoms on this side and 2 carbon atoms on this side, right? So if this compound were to show meta-isomerism, then I will exchange one of the carbon atoms from this side of the functional group to the other side. So it will become methoxypropane, right? Because I shifted one carbon atoms from this side to another side, so it became methoxypropane. So both of them have the same molecular formula, but the structure of both of the molecules is different, and this kind of isomerism is known as meta-isomerism, in which the number of carbon atoms on both sides of the bivalent or polyvalent groups change, but the functional group remains the same. One of the important rules for meta-isomerism is that the functional group of the molecule should not change. Okay, the functional group has to remain the same. If this is an ether, then this should be an ether too for it to be meta-isomerism. Let me give you some more examples. Okay, one more example. Let's consider methoxymethane. So if I were to shift this carbon from this side to this side, then this will become this, right? So is this meta-isomerism? No, it's not, because one of the important rules for meta-isomerism is that the functional group of the molecule should not change. Here it is an ether, but here it's an alcoholic group. So the functional group is changing. That's why this is not considered meta-isomerism. Though this is functional isomerism, which we will study about later. Okay, let me give you some more examples. Let's consider this. We just studied that this will not show meta-isomerism, and similarly, if we had this will also not show meta-isomerism, because if I shift the carbon atom here, then it becomes an alcoholic group, so the functional group changes. This also will not show meta-isomerism because there's only one carbon this side, so I cannot shift this carbon here, and if I shift one of these carbons here, then we get the same molecule which we had in the beginning. And let's take another example. Let's take this will also not show meta-isomerism, because if I shift this phenyl group here, then it becomes an alcohol. Let's take another example. This, we just studied this example. This shows meta-isomerism. and this will also show meta-isomerism. Why? Because if I can shift one of these carbons here, right, so the functional group stays the same, but the carbon atoms on the both the sides changes. So let's take another example. Okay, let's take this. So this compound, will it show meta-isomerism or not? We will draw different meta-isomers for it. So we have the benzene ring on one side and we have the ethyl group on the other side. So let's draw different meta-isomers for this. If I were to shift this carbon here, then I will get this. So the functional group stays the same, but the number of carbon atoms on the both sides changes. So this is a meta-isomer of this. And if I were to draw more, then I can draw them like this, and we can also make this, and we can also make this. Okay, so even though these are all different compounds, these are all meta-isomers of this compound. Okay, now let's talk about these three, this one, and this one. These three are actually position isomers of each other. Why? Because the position of the methyl group is changing from ortho to para to meta. Okay, and they are all meta-isomers of the former compound, former molecule, this one. Okay, now let's move forward and I will give you some more examples. For example, this will show meta-isomerism. In this example, this ring is our functional group. So this is the bivalent group which I'm talking about. So we can shift the carbon from this side to this side, this side to this side, and it will show meta-isomerism. And another example could be, we could have a benzene ring or cyclic group, any cyclic group, and we can have different alkyl groups attached on either sides. This will also show meta-isomerism. Now I will give you some examples, and we will do this small activity where we match different examples and find out what kind of isomerism they are showing. Okay, now let's take three compounds. The first one is this. And the second one is this. And the third one is this. Okay, we will consider them one by one and we will see, we will compare each pair like 1, 2 and 2, 3 and 3, 4, sorry 3 and 1, and see what kind of isomerism they're showing. Let's consider 1 and 2. So when we talk about 1 and 2, in 1 and 2 the number of carbon atoms on either sides is changing. In 1 the number of carbon atoms is 1 and 3 on either sides, and in 2 we have 2 carbon atoms on each side of the bivalent functional group. Okay, so they are showing meta isomerism. And if we look more carefully, we can also notice that the position of the functional group is changing. Here the position of the functional group is 2, and here the position of the functional group is 3. So the position of the functional group is changing from 2 to 3. So it's also showing position isomerism. Now let's talk about 2 and 3. Okay, if I look at 2 and 3, then the number of carbon atoms on either side of the functional group is different, so it's definitely showing meta-isomerism. And if I look more carefully, then look at this, the main carbon chain is also changing. Here the carbon chain is of 5 carbon atoms, whereas in the third molecule, the carbon chain consists of 4 carbon atoms, so the main chain is changing as well, so it shows chain isomerism. Now let's talk about 3 and 1. Okay, if we talk about 3 and 1, then the number of carbon atoms on either sides of the functional group stays the same. It's 1 and 3 in both 1 and 3. Okay, so but the main difference is that the chain is changing, the main parent chain is changing. Here the chain consists of 5 carbon atoms, whereas in third molecule the chain consists of only 4 carbon atoms. So 3 and 1 show chain isomerism. Okay, please practice a lot more, do a lot of questions, then maybe you'll understand how to identify what kind of isomerism a given pair is showing. Okay, so this we can conclude that chain and position isomerism will never coexist together. As in position isomerism, chain will have to remain the same. So as we saw that we can see meta isomerism in them, but either position or chain isomerism will exist. Both cannot exist together, because for position isomerism the parent chain should be same. I will write it. Chain and position isomerism never occur together. As in position isomerism, chain will have to remain the same. Okay, now let's take one more example. We have three molecules again. This, and this. Okay, now let's consider them one by one. This is 1, this is 2, and this is 3. Okay, now let's consider 1 and 3. 1 and 2. Okay, what do 1 and 2 show? The number of carbon atoms on either side of the functional group is changing, so it shows meta-isomerism. And in 2 and 3 you can see meta-isomerism. Okay, and in 1 and 3 the number of carbon atoms on either side of the functional group remain the same. It's 3 and 1, right? The only difference is position of functional group is changing. Here the position of functional group is at the second carbon, whereas in this it's different, so it shows us position isomerism. Okay, practice a little bit more, do a lot more questions, then maybe you'll understand better how meta-isomerism and position and chain isomerism work. If you guys have any doubt, feel free to ask it in the comment section. Please give your suggestions, and thank you so much. We'll study about functional isomerism in the next lecture.